afternoon, everybody. I got a lot of content to get through today, so thank you all for coming out. Today we're going to be going over a use case of a multi-stage Broadway pipeline that we've built at GetThru to send text messages. My name is Brian Meeker. I spend my work hours as an Elixir dev at GetThru. I only started working professionally in Elixir a couple years ago. It's my first ElixirConf. I'm very excited to be here. That's me very excited after jumping out of a plane last month. You can mostly find me these days on Mastodon. These slides will be available on GitHub afterwards, and there'll be a QR code link at the end. So GetThru provides texting and calling tools for progressive political campaigns, nonprofits, and universities. As you might have noticed, it's a presidential election year in the US, and that means a lot more usage of our system, and that led us to reevaluate our infrastructure to handle the load. We have two main products. For today, though, we're only going to be looking at through text. You might send a text about your university's giving day or about a Get Out the Vote campaign. People don't want to answer phone calls from an unrecognized number, but they will at least glance at a text message usually. Before we get started to look at our system, let's go over just a little bit of domain terminology. First, we send text messages, and we do that through providers. We don't talk directly to carriers. Instead, providers are the services we use to send text messages through. Everybody here has probably heard of Twilio. There's a bunch of other options out there, and we use multiple of them. Mobile network operators are carriers like AT&T, Verizon, T-Mobile, and US Cellular. And the US, that's basically it for physical infrastructure. And importantly, we need to know who the carrier is for that phone number when we're sending a text message. And in our industry, there's sending limits that are regulated by an industry group called the Campaign Registry, or TCR. Our old system had its issues, but this is what really broke it. TCR is an attempt at industry self-regulation by carriers to prevent federal regulation on their industry. They require brands to submit information about themselves and their campaigns up front so they can know who's sending a campaign and what it's going to be about. The quality of the information they submit and their use case is part of determining if they will be approved at all, and if they're approved, what their rate limits are going to be. TCR was announced in 2021, it went into effect in 2022, and our system has been muddling along with it ever since. So in 2023, it was decided that we needed to start fresh, and building on the old system wasn't sustainable anymore. This fresh start is built around Broadway and Rabbit. Broadway is completely new to us. We already had limited use of Rabbit in our stack, but this project was really going to force us to learn how Rabbit actually works, and we'll get to some fun stories about that. And we codenamed this new project the Super Collider. I've kind of rolled my eyes at codenamed projects before, but AI image generation has made it more fun than it used to be, at least. So this is it. This is our pipeline. Let's ship it. Does anybody have questions? Maybe we should go over this just a little bit. We don't have time to go through a whole bunch of it in detail, but we can speed run through it so we can get to the interesting parts where we broke it. So our pipeline starts when a user clicks a button to send a message. We want to make sure that this message gets into our database up front. Our legacy system did this too, but it did them one at a time. Now we bulk ingest them in batches through Broadway. One of the goals of the system was to lessen the load on our database by batching and inserting a whole bunch at one time. That helps us out. We have a monolith, we have one database, and we'd like to keep it that way as long as possible. Then after each message is sent, we send along to the correct queue. Our customers send messages as part of what we call campaigns in our domain, and it looks roughly like this. Each campaign gets its own queue and consumer. When a campaign is launched, we dynamically create that queue in RabbitMQ for that campaign. In addition to the GetThru campaign queue, we're going to dynamically start up a Broadway consumer process, and that process will start consuming messages from that campaign queue. Most of our pipeline stages are very simple. This stage exists purely to check if we're how we're going to route the messages. There's different rules for the US versus the rest of the country. And importantly, you're only supposed to text at certain hours of the day, depending on the campaign. So we completely shut off the Broadway consumer at certain times of day, so we don't, send you a text message at midnight. Non-US campaigns aren't subject to TCR, so we can push messages directly to our send message stage. And this is where we make an API call to one of our providers to actually send a text message. So there are separate queues for both SMS and MMS messages for each provider, and this is because they have separate rate limits. So a provider may say we could send 500 SMS messages per minute, but only 250 SMS messages per minute. And this is all done through Broadway back pressure. We tell Broadway how many messages we want in a certain interval, and it will reach out to Rabbit, request that many, and we'll never exceed our rate limits because of that. So assuming a consumer can successfully send an SMS or MMS to the provider, we then publish 2 Rabbit messages. One goes to a bulk update queue, and the other is going to go to a side effects queue. Now that we've made our API call to the provider to send a text message, we still need to update our database to reflect the state that the message has been sent out. As messages are going through the pipeline, we don't update our database at all, because once again, we want to lessen the load on that. So at the end, we do, similar to bulk ingest, we do bulk update. So we bulk update it to our database, and then we broadcast information about that message. So maybe the UI needs to update in some way. Maybe there's other side effects in our system that we care about. In many other ecosystems, this would be another job for the message broker. Like you could push more messages to Rabbit, but we just use Phoenix Pub Sub for this. So like we don't care about these being durable at all. So that does it for our non-US customers. But what about this big middle part of the diagram? This is where the campaign registry and carrier rate limits live. So TCR is carrier industry's attempt at self-regulation of A2P text messaging. They want to allow as many of these messages as they can so they can get their money for them, but not be so annoying that the federal government actually steps in and regulates them. So we end up with separate queues and consumers for each carrier and each TCR campaign combination. TCR tells us what our rate limits are for each carrier, and all these rate limits are enforced through back pressure except for T-Mobile because they're special, and they want us to have a daily cap, and that back pressure through Broadway doesn't work well for a daily cap when you're doing deployments, and you need to be durable between those. So that was just a speed run through our pipeline. There's other parts of the system too as well. So we have these campaign sending windows. So we're only allowed to send messages at certain times of the day for a campaign. And the way we enforce this is by dynamically creating parts of our topology when a campaign opens, and then tearing it back down when the campaign closes for the day. And we lean hard into processes for this. So this is a simplified supervision tree for this part of our application. When the application starts up, we create a campaign worker process for every active GetThru campaign in our system, and each campaign worker process is responsible for managing the Broadway consumers. So let's look at a simplified example here. Let's say we start our application up at 7 a.m., and this campaign is scheduled to start at 8 a.m. No consumers have been started for this campaign yet, so it's impossible for us to accidentally send messages out. Even if there are messages in the campaign queue, we're not going to send them. So campaign 1 schedules a message for itself at 8 a.m. to start the campaign. 8 a.m. rolls around, the message gets delivered to the campaign worker process, and this starts all the consumers for the campaign. Once those are started, the campaign worker schedules another message for itself. This time it's for 9 p.m. when the campaign closes. 9 p.m. rolls around, closed message is delivered, and it shuts down all the consumers. Then it schedules another message for itself to start it all up again at 8 a.m. the next day. Now, we had most of this done way back in January, and then it was time to start some serious QA before rolling it out to customers. We had been testing as we went along. We assumed things would be fine. It was not fine. So what had happened? What did we miss? Beyond the normal bugs when implementing a new system, there were a couple of large issues that we missed that needed to be addressed. The first was UI related. We had been seeing a number of oddities in the behavior of our UI when developing the pipeline, and we just kept putting them off. We thought they couldn't be a big deal. They were completely unrelated. Our UI is completely decoupled from this new pipeline. There's no way that there was a problem here. And of course, we were wrong. The existing message sending UI didn't handle the new pipeline well because it had made a lot of implicit assumptions about latency and how messages were being inserted into the database. For various reasons, we ended up having to declare tech debt bankruptcy and had to fork the most complicated live view in our application that actually manages sending these messages. to a version that would work with the super collider so that we could keep the legacy version working as well while we rolled it out to customers. What we had thought would just be some quick bug fixes, and then thought would just be some changes that broke backwards compatibility, ended up turning into a full rewrite of the core logic of these UIs. In the long term, this is a good thing. We were able to drastically reduce the database load at our system more because we were doing some stupid things before. We used to hit the database constantly to load new data. Now we're doing optimistic UI updates when we're ingesting these messages. And then I mentioned the pub sub and bulk update earlier. We can update the UI later. So now we do all this with very little traffic in our database. We ended up in a better place, but it was a lot of pain to get there. That was unexpected and we did not budget for. So the lesson here is just don't assume that these parts of your system are decoupled. We had bugs that we should have been paying attention to, and if you can't explain them, you should probably pay attention to them as well. We ran into one other large issue. We're actually supposed to rate limit SMS traffic by segments, and segments are sections of an SMS message. So what we really wanted was a weight on a message so we could say how much it counts towards the rate limit. So if a message is 3 segments, we want it to count 3 towards the rate limit. Then we can continue to rate limit through back pressure. The problem is Broadway doesn't support this out of the box. So we forked Broadway internally and modified the rate limiting to support weights. We haven't talked to the Broadway team about contributing this back. You can't hook in a custom rate limiting module right now, which is probably what we would need because adding weights to messages adds a whole bunch of corner cases that you can really shoot yourself in the foot during configuration. So it's probably not a thing you want to be in core Broadway. That was a quick overview of the domain and just some lessons learned before launch. If you want a more thorough breakdown of all of that, there's a 60-minute version that I just speed run through today back at Stir Trek in May. That QR code will take you there. Or if you just search the name of this talk, it'll come up on YouTube and you can find it. The real learning, though, starts when you start using the system in anger. So back in May, we turned the system on for just a few customers to kick the tires on into production. That went fine. We had a few bugs here and there. No big deal, though. We fixed them pretty quick. We're sending messages. The super collider was great. Life was going to be perfect. Then it was time to turn it on for the first full release group. And amusingly, I was on vacation. I was relaxing in the mountains of Tennessee, completely disconnected from the world, while my coworkers were dealing with our first incident. One of the advantages of working in a domain where the system is unused at certain hours is that you have convenient release windows. And so we decided to take advantage of this to turn on the first release group in the middle of the night. So one of our engineers dutifully clicked the button, and Rabbit immediately became unresponsive. Our error monitoring spammed Slack with so many messages that Slack became unusable. Rolling back the release group and getting the system stable again took a few hours while I was blissfully sleeping in a cabin in Tennessee. The issue just turned out to be something we had noticed but not taken seriously. So this here is a chart of our connections to Rabbit. Can you guess when the button was clicked? We were seeing a one-to-one relationship between connections and channels on Rabbit, and it turns out this is the default behavior of the Broadway Rabbit MQ producer. Every producer will create a new connection to Rabbit, open a single channel on that connection to manage consuming messages from a queue. And this works fine if you have a limited number of consumers. We were spinning up 12,000 of them. So this one-to-one ratio actually violates the Rabbit MQ recommendation to create few connections with many channels. The good news is that the Broadway Rabbit MQ producer allows you to pass in your own implementation of the channel pool behavior. So when configuring the consumer on your producer, you can pass in a configuration for a custom pool. And this is just the example implementation from the docs. You can see here that there's only 2 callbacks you have to implement, checkout channel and check-in channel. There's some existing libraries out there, but we decided to roll our own. So on application startup, we create a connection to Rabbit for each Beam scheduler. By default, there are 2 schedulers per core. So this example is showing the situation of just a 1-core machine. When you're checking out a channel, each producer is getting a connection for its scheduler and then opens a channel. So here you can see the 3 channels been open. There's 2 on one connection, 1 on the other, and each producer now has access to a channel. When a producer closes, it attempts to check the channel in. Now you can see that the producer's closed, the channel has been closed, but the underlying connections still exist. So this is working pretty well for us. It allowed us to turn the super collider on successfully for the first release group, but it also showed the need for one other tweak, which was, we were the thundering herd in this situation. Elixir is great at spinning up thousands of processes in a very short amount of time. However, we quickly realized coming out of this that we needed to throttle how fast these consumers were being created. Because even with creating all these channels just on a static number of connections now, it's still a lot of channels to be creating all at once. And Broadway is going to create to those consumers right away. And then another thing is Broadway will actually create the queue for you if it doesn't exist. So when we are turning on these release groups for the first time, there's a one-time hit where we're also creating many thousands of queues at once. And Rabbit was a little unhappy about that. It didn't fall over this time, but it spiked the Rabbit resource users enough to spook us. So don't be the thundering herd. Processes are cheap to spin up, but you really need to think through what those processes are doing. If they're talking to external systems, they may not handle it as well. Even before this incident, we had not been happy with AWS's RabbitMQ offering, Amazon MQ. It didn't give us the kind of observability we wanted. It severely limits how you can get metrics out in a way that doesn't bloat your AWS bill. They don't support the Rabbit Prometheus plugin. They want you to query CloudWatch instead and then charge you for it every time. Not an advertisement, but we switched to Cloud AMQP. Now we get all the metrics we wanted to Datadog. In addition, it's been really easy to get a hold of somebody when something goes wrong, such as when you open so many connections that your server becomes unresponsive. After making those fixes, we were able to successfully turn on the super collider for our first release group. We didn't have any large incidences in with this release group, but we did have a number of smaller issues to address before we went and turned it on for more. First, we would sometimes get unrouted messages. The campaign and carrier queues in our system are created dynamically, and if something went a little bit wrong in that, we could be attempting to send message to a queue that didn't exist yet. And it didn't fail in the way we had expected. We had expected that setting the mandatory flag in AMQP when publishing a message would cause an error to be returned. That's not actually what it does. Instead, it just returns OK, and then you are supposed to register a handler for a basic.return message that's going to come back to you. So if you don't register this handler and you have unrouted messages, you will get a warning in your logs saying there was an unrouted message from Rabbit, and then the system will dutifully continue as if nothing went wrong. This here is an example of the default behavior in Rabbit. We have a Rabbit exchange, a couple of queues, and a couple of bindings. When a message gets sent to that exchange with a routing key of bad route, none of those binding match, so Rabbit doesn't match it to any queues. It just drops it into the void and sends you back a basic.return that you should deal with. Instead of implementing this handler and dealing with what would now be an asynchronous publish operation, because we couldn't rely on just getting back an error when we published, we went with a solution in Rabbit itself. So Rabbit allows you to create what is known as an alternate exchange. If you send messages to an exchange and no bindings exist to handle that message, then it's going to get sent to the alternate exchange instead of sending a basic.return back to you. Our alternate exchange is dumb. It just has one binding to a text.unrouted queue. We have a consumer that watches this queue for messages. It consumes messages, emits a metric that alarms for us so we know that something went wrong, and then just sends it to a dead letter queue. So now in the rare event that we do get these unrouted messages, we're going to get notified that something's wrong. We can intervene as needed. This usually means creating the missing queue, shoveling messages back over, and then debugging why it didn't exist in the first place. Open telemetry is great. We're huge fans. We send a ton of telemetry to Datadog. They're very happy about how much we send them. It isn't free, both in dollars and processing time. But it's a terrible feeling to seeing your system melting down and your dashboard stop working because you're sending so much telemetry that your Datadog agents can't keep up. During one incident, we were logged 1 million error messages in a 15-minute window, and Datadog was not keeping up. And you risk your metrics, like you're trying to debug through these dashboards, and if they're not accurate, they're at best worthless, and At worst, very deceiving. But even in this non-pathological case, we knew that our telemetry was unsustainable. We had been turning it down. During development and the initial rollout, we had kept the logging and traces very high, just out of paranoia so we could see what was happening and what was going on. We also know that our traffic is very bursty. A very common usage pattern for us is very low traffic with spikes as customers launch large campaigns. And those bursts, we don't want those to lag in the Datadog agents as well. So between these bursts and error states, you need to keep your worst case scenario in mind for telemetry. How is it going to hold up under pressure? While trying to fight another issue with duplicate text messages being sent, we started immediately acking message in each Broadway consumer. And this had an unfortunate side effect that caused us to roll this back very fast. It turns out that you can't fail messages after they've been acked, and when you say that out loud, you realize how stupid you were for thinking it could be any other way. You've told Rabbit that you're handling the message, and then it doesn't have to care about it anymore. So of course you can't fail it after that. We noticed this pretty quickly when we saw we were having all these retries, and it would get to the end of the retries, and it's supposed to go to the dead letter queue then, and it would just disappear because we've told Rabbit it was fine. Speaking of retry queues, they've been a recurring focus for us. Our retry strategy is based on this article by Brian Storty. If you're building an event or message-driven system with a lot of retries, I highly recommend reading this article. You can do some bad things in Rabbit with retries. So this here is where we ended up. So our application publishes messages to an exchange, which get routed to a queue, and a Broadway consumer processes those messages, and let's just say something goes wrong. In that case, we calculate a time to live, a TTL, and we publish it to a retry exchange. And based on how many times the message has failed, the message is going to go to a retry queue where every single message has the same time to live. And this is important because Rabbit messages in a queue can only expire in order. If you have messages behind that are expiring before the message in front, too bad. They're just going to sit there and wait. If every message in the queue has the same TTL length, though, they can expire in order. So when that expires, we send the message back to our original exchange and route it again for retry. We made some mistakes in getting here, though. First, we were dynamically creating retry queues for each queue in our system, and this was unnecessary. It risked an explosion of queues in a worst-case scenario, where so if an incident is causing more messages to start retrying in our system, and all of a sudden we're creating more queues, and the incident is very bad, all of a sudden we risk cascading failures, and that's not a place you want to be. Most of our retries are exponential backoff. We have a set of 10 static retry queues, one for each attempt. All messages in the first retry queue have the same TTL, so on and so forth. And this just gives us a predictable static amount of resource usage and eliminates any of these issues with dynamic queue creation for us. For domain reasons, T-Mobile is special because T-Mobile is always special. T-Mobile has a daily cap instead of a per minute or per second rate limit. So once that daily cap is hit, we know that the messages can't go out and they can't go to the next day. So when they get shoved in their own special T-Mobile retry queue that has a TTL in the middle of the night, and they will just expire and get retried the next day. That fix also fixed a bug where QTTL didn't work as expected. This is a case of please read the docs and read them correctly, and then read it again just to make sure. We had thought that the QTTL would reset when a message was published to it. That is wrong. QTTLs only reset when a consumer connects to them, and no consumers ever connect to our retry queues. So the TTLs were never reset, and depending on the timing of when things were set, that meant we could lose some retry messages, which wasn't a good thing. But that's all fixed now. So after addressing the main connection and channel issues in the first incident, we continued to roll out the super collider to more release groups. And the next to last one was going to add a decent amount of load to Rabbit, but we thought we were fine. We knew from our monitoring that our memory usage was a bit high, but it was tolerable. Unfortunately, we didn't have good monitoring on other resources in Rabbit, such as CPU usage. So one morning after an unrelated deployment, we noticed that messages had stopped sending about 10 minutes ago, and then we got paged. The system was crumbling before our very eyes. We had gone from a steady state of about 60,000 channels in Rabbit all the way up to 400,000. That's our CPU usage. It might be a little hard to read. It's up at 100% there, basically. Every node in the cluster was pegged at 100%, essentially. Memory was using a large amount of swap, and we were unable to get the system under control and had to start disabling the super collider for each release group to try and recover. This rolled customers back to our legacy system, which luckily was still there and still working for our current use case, so they could send messages while we surveyed the wreckage. So I mentioned earlier that Cloud AMQP support is great. This is one of those times they had to restart our servers for us. To the best of our knowledge, this is what happened. We do blue-green deployments. We spin up a few nodes. We wait for them to be healthy, then shut down the old nodes. This means that on each deployment, our system has more nodes than usual for a brief amount of time. And we did not take this into account when evaluating our Rabbit resource usage. With Rabbit pegged at 100% CPU, we think that the channels became unresponsive. In response, the Broadway Rabbit producer just started creating more channels. And that's how you end up going from 60,000 to 400,000 real fast. This incident was embarrassing for us. We had some customers not have their text messages be sent. We hadn't understood the behavior of our system well enough to head off what should have been an obvious risk. We had been watching the memory usage, and we thought we were fine, and we were not. So in addition to code changes, we increased the size of each node in our Rabbit cluster and improved our monitoring. The good news is that all traffic was now back on the legacy system, so we had an opportunity to do some invasive fixes that would have been more difficult while it was in use. One way to deal with our resource usage was to look at the sheer number of dead letter queues that we have in our system. So every single campaign had its own dead letter queue. Every single carrier queue also had its own dead letter queue. And before we deployed, we thought this was going to be fine. We had benchmarked how much memory a queue used. Unfortunately, we hadn't accounted for the overhead of running on a cluster, and we hadn't accounted for the fact that we switched from classic queues to quorum queues at some point, and those use more memory. So we obviously should have benchmarked again, and we didn't. So looking into the wreckage of this, we saw that our queues were using more resources than we expected, and we were able to simplify things. So now that the system was shut off, we consolidated our dead letter queues. All campaigns now use the same dead letter queue. So all those TCR campaign queues, those now send messages to the same dead letter queue. Now we go from tens of thousands of them down to 2. The downside here is you can't blindly shovel messages back and forth. You have to actually know what the destination is because they didn't all come from the same queue to begin with. So we had to write some custom tooling for this. That wasn't too bad, though. And honestly, the interface for that was much nicer than the generic interface that Rabbit gives you. Once you get over about 10,000 queues, the Rabbit management dashboard, looking at queues, kind of becomes unusable. So this kind of tooling was important for us anyways. With the system down, we also took the opportunity to change our queue naming strategy. In short, read the docs. The big thing to understand is that Rabbit wants you to use dots as the delimiter between words in a queue name, and then you can use pound and star as wildcards and routing keys. We had made the mistake of mixing in underscores in there too, and this wasn't hurting us, but it limited our ability to route messages in the future. And it was taking away flexibility for no good reason. So after we brought the system up again, we had one other change to make. In Elixir, we often bragged to other communities about how little memory our processes use. This gets thrown out the window if you do stupid things at scale, though. Yeah, the Beam process itself is cheap. Gen servers are cheap. And if you have thousands of them, though, and you're doing something stupid, it's not so cheap anymore. This one didn't burn us in any way. It could have in the future. The issue was we were passing ecto schemas into our processes as state. That's reasonable to pass it in that way. But then we were just storing the ecto schemas as the state instead of pulling out the pieces of information we need. Making this change saved us over a gigabyte of memory on every single node in our system. And that brings us to our final big incident. This came from a change that we thought was pretty safe. Verizon wants us to limit messages per phone number, not per TCR campaign. All right, we're making the change. That's going to add 10,000 more queues to our system, along with the consumers for each of them. It was a lot, but we had bought ourselves some overhead, so we were fine. Instead, we got hit by an unexpected problem, one that I had been wondering about, actually, in weeks leading up to this. Who's seen this error message in production before? Too many processes. System limit has been reached. I had been idly wondering what the behavior of the beam was when this happens, and now I know. Before this project, we didn't create too many processes ourselves. Of course, we had them for Phoenix requests and LiveView and Ecto and all the other usual suspects, but we didn't use a lot of processes for our own code very much. And we had noticed that the usage was creeping up, but we still thought we had more room. This was another issue where we didn't have good monitoring or alarms. When turning on the release groups in the middle of the night, I had been checking the processes, and we were about 30%. What I hadn't been realizing was, oh yeah, we're turning things on during the day as campaigns open up, and we were peaking at about 60% during the day. So Rabbit wasn't going to have any issue opening up all these consumers, but our Elixir nodes reached the process limit. We were creating about 12,000 new queues in Rabbit and Broadway consumers. Each Broadway consumer is a supervision tree with about 7 processes. So we were attempting to create about 84,000 new processes, which took us just above 100%. Luckily, this was pretty early in the morning. The system wasn't being used that much, so we were able to quickly roll back this change and clean up the data. I quickly read a script to delete all the new phone number queues in Rabbit while we tried to figure out what was happening. And while someone else was reading the docs, like, okay, how do we up the process limit? We haven't actually done this yet. There's just a flag you pass. We actually postponed this work. It wasn't absolutely necessary for now. We'll get back to it. We'll do it right the second time. So shortly after that incident, we were able to turn on the final release group, have all traffic flowed through the super collider. Everything was great, big party. We now fixed several other issues, though. So incident responses have been painful for us because we didn't have good tooling to recover from them once the system was running again. After the process limit incident, we got more serious about this. We now have tooling to shuffle messages around from DL queues back to their origin as we need. This took something that required navigating painfully through the RabbitMQ management plugin or working directly in IEX and prod, which is something you can do and is fantastic, but if you're doing it all the time, you're doing it wrong. We also got a nice dashboard out of this so we can get visibility into what dead letter queues are actually being used right now. And that's just been a huge time saver for us. Another one was just a button to restart TCR campaign consumers. Sometimes we get stuck with unact messages. I don't know what the bug is, but kicking them helps. We're also experimenting with cron jobs to proactively look for campaigns that are degraded. We need to put some more thought into this. We ran into the issues like, okay, what does it really mean for a campaign to be healthy versus degraded? We have the infrastructure there for it. We just got to think through what that actually means. Another win has just been taking the time to improve our monitoring and Datadog. Telemetry is only one point of observability. You need to really be able to do something with that telemetry. What do you want to do with it? Do you want it for historical reasons? Do you want it for monitoring incidents? So take the time to learn your monitoring tools. We use Datadog. It's an incredibly complicated tool. There's so much you can do with it. We're still, I'm learning new things all the time, but it's definitely worth the time to learn how to use it. And another minor one was just consumer creation order. We have a multi-stage pipeline. Sometimes we would get unrouted messages, and it turned out that's because we were creating our consumers from front to back in the pipeline. And so sometimes stuff would be spun up and start processing messages before the next stage had been created yet and the queue didn't exist. And then the message would be unrouted. So our lesson here is just start your pipeline up from back to front in our use case and shut it down from front to back. And that's roughly where we are today. We do have several other improvements on the docket, though. We're hoping to get to some of these before the election, but others are probably going to wait till after. First, do not share channels across processes. We talked about the Broadway custom channel pool earlier, and that solved it for Broadway consumers for us. Did not solve it for us when we publish messages, though. So let's say you have process A that's getting a name channel through AMQP. Process A now has a reference to channel 1. It's a process with a PID. Process B is also getting a channel with the same name now. This is the same channel. It's the same PID. Now you have the same channel being shared across processes. This directly contradicts the RabbitMQ docs. Do not do this. Process A then attempts to perform an action on the name channel that causes the channel to be closed. Process A knows that something is wrong. It knows that its channel is bad now. Process B does not. It thinks it has a fine channel still, and it's not going to know it's bad until it tries to perform an operation on it. AMQP will reestablish the channel, but it's going to be a new channel with a new PID, and you have to get that name channel again. While I've been at ElixirConf, I think one of my coworkers was working on fixing this. It's probably the highest priority, like, this is just wrong bug in our system right now. And we're pretty sure it leads to sudden bursts of errors we sometimes see. The solution is simple. Just don't share channels across processes. Currently, we have individual campaigns that we can pause to stop their messages from processing. That's a nice start, but it'd be better if we had the ability to turn each stage on and off. At the very least, we'd like to be able to trip these breakers manually. Ideally, we could look at automating them. For example, if we're sending a text message through Twilio, their API is having issues, a certain percentage of errors could trip the breaker for us while we triage. Currently, for every campaign, we run all the consumer processes on every node. If we have 5 nodes on our cluster, that means we're dividing the rate limits by 5 and running it all over the place. The question becomes, how much redundancy do we actually need? It probably isn't necessary for us to be running all these consumers on each node. Most of them sit around doing nothing all day because the static consumers and queues constantly see traffic, but the ones per campaign is only when the customers are actually using it. So how many should we be using? We should probably be looking at tools like Highlander and Horde to figure out what we're doing. My initial impression is that Highlander is probably a good choice for us, but this is another case where we need to use these in anger to figure out which one is a good use for our use case. We've also had to turn down telemetry to avoid burying our Datadog agents, and so we've lost some of our nice audit trails. It would be nice to get those back. We've talked a lot internally about options to do this. We'll get to it at some point. And then finally, it's not clear we should be using Broadway at all. Given our use case, it's possible that we should just be using GenStage directly to build our ODE pipeline. We've already forked Broadway so we can add weights to messages. Maybe we should just be doing that at the GenStage level. I think that using Broadway is absolutely the correct decision to start. We did not have a good enough understanding of the problem space, Broadway itself, or GenStage, but it may not be correct for us long term. We need to think about this some more. If you want to learn more about the differences between Broadway and GenStage, I highly recommend this book, Concurrent Data Processing in Elixir, to better understand that separation. It really clicked for me when I read this book. So many thanks to everybody I work with at GetThru. I'm the one up here talking, but the entire team worked on this project in various ways. That we have 6 people. Like, there are 6 engineers on our team. That's it. We're pretty happy with what we've built right now. We recognize there's a lot of polish to be done over time. We're confident that we have a system that can stand up under the load of an election season. If you have any questions, come up here and chat with me. You can also track down my coworker, Chris, sitting there. The slides will be available on GitHub. You can find me on Mastodon. Thank you, and enjoy the rest of your day.